Hey guys, today we are going to see how much water can come out of our shower in 30 seconds. You will need someone to keep track of the time. I'm gonna pretend. I'd recommend a stopwatch. So
let's do this, Will.
let's do this.
Ready and collect. Should we pretend that like that's 30 seconds? Okay.
Okay, so 30 seconds later.
You have some water in your bin, huh?
Mm-hmm.
Now, how do you think we're going to try to figure out how much water is in that bin?
Let's use a measuring cup.
Oh, look, there's a measuring cup sitting in our bathroom. How convenient. So when you measure that, this happens to be a 2-cup measuring cup. You just need to figure out how much water is total in that bucket for your 30 seconds. Use whatever measuring device you need, and then you can use Google to convert it into gallons. All right, thanks, Will, for introducing us to the shower lab. So you should hopefully see the shower lab now. And what Will just showed us, he showed us this, kind of this part. So what are we actually going to do? So the big idea is we're going to go through, we're talking about heat gain, heat loss. We're going to figure out how much money it costs to heat up hot water to take a shower. So in order to determine that, first we got to figure out how much water is coming out of a shower. So that's what Will was showing us. We're going to turn on your shower and you're going to collect it for 30 seconds. Notice how Will, he did this actually on his own. He turned it to cold water. It was in the instructions, but he didn't know that. But to cold water, so we don't have to waste hot water. There's no real point. You just got to make sure you turn it on so it's at full blast. Like all the water that would come out during your shower is coming out. So you're going to go through and time it. We pretended to time it for 30 seconds, but you actually need to time it for exactly 30 seconds. Then you take a measuring cup to figure out how much water came out. Now we had a 2-cup measuring cup, so we filled it to 2 cups and then we dumped it out. We filled it to 2 cups and then we dumped it out. And we kept doing that until we had like 16.3 cups of water, something like that. Now yours is going to be more. Typical showers are going to have like 2.5 gallons per minute, so you're going to have right around the like 1.5 gallons of water. So make sure your container is big enough for about 1.5 gallons of water, just so you're aware of that. Some are a little bit higher, some are a little bit lower. But make sure your container is appropriate. Now, we happen to have a handheld shower nozzle, so it was really nice. You could just point it right in there. If you don't, just hold it up near the top, and you need to collect all the water that's coming out of your shower head. And then once you determine how many cups, then use Google and figure out how many gallons. So 32.6 cups in gallons, hit search, and it's going to tell you how many gallons came out of your shower head. Okay, so in this, I went through and I numbered all of these kind of steps by 1, 2, 3, 4, 5, 6. And the idea is so I can go through and I can reference. So how do you determine your flow rate in gallons per minute? Well, you take your number that you wrote in number 2 and then you double it. How do you determine the volume per shower? You take your answer from number 3 and you multiply it by number 4. So that's what these are over here. And that's why they're numbered over here. So how many people are in your family? This is what you just measured. That's gallons per 30 seconds. We want gallons per minute. Well, that's half of a minute, so we just say times 2. That's gallons per minute. Then you need to determine how long your average shower is. When you get in the shower the next day, take a look at the clock when you get in and look at it when you come out. And what's your average? Doesn't be exactly, but is it a 10-minute shower? Is it a 30-minute shower? Is it a 2-minute shower? That's what we're looking for. So then if you know gallons per minute and you know how many minutes, then you can go through and you can determine how much total water came out of your shower, which is great because then we can determine how many kilograms of water. So there's a conversion factor. There's 3.7854 kilograms per gallon. So you take the number of gallons times that, and it'll give you kilograms per shower. And the reason why we need that is we're going to use the Q is equal to MC delta T, and we need to know the M, and that's going to be our M. But when we when we buy water from the Village of Weston, we buy it in gallons. So then we have to go back to number 5, our gallons per shower, and we buy it. And these numbers these have been a couple of years since we've updated these, but it's less than a penny a gallon. So 0.00878 dollars per gallon. So take gallons times that, and we'll give you that. My guess is going to be right around 25 cents, somewhere in the ballpark, give or take 15 cents, somewhere in that ballpark. So that's how much it costs to buy the water. We're assuming everyone lives in the Village of Weston, which it isn't really the case. Some of you in the country, I know, but whatever. So now we got to heat up the water. So in the state of Wisconsin, average groundwater temperature is right around this 55-degree mark. So that's 12.8 degrees Celsius. And an average shower temperature, some people take warmer, some people are colder, is right around the 110 degrees Celsius. So when we go Q is equal to MC delta T, remember delta T is final temperature minus my initial temperature. So 43.3 minus 12.8. So that's what this is kind of walking us through, is these steps and these numbers. So we're trying to determine Q. Q is equal to MC delta T. So mass, how much water did we use? That's from number 6. So my M, here's my specific heat of water, 4,186, times delta T, 43.3 minus 12.8. Remember, parentheses. Delta T is equal to TF minus TI. So remember that. So then you have that. Then you need to go through, and that's how much actually goes into heating the water, but nothing's 100% efficient. So an electric hot water heater is about 99% efficient because the heating element is completely submersed in the water. So it's pretty efficient, but we lose a little bit of heat through the outside insulation. So it's about 99% efficient. And these are actual like efficiency ratings from hot water heaters that you go to like Menards or Home Depot and buy. So what we need to do is we need to account for that total energy, the energy that we wasted. So we're going to calculate the total energy used. We're going to use this equation right here. So 99% efficiency is an electric hot water heater. What you just calculated in number 8 is the Q to heat the water, which goes right here, the energy that goes into heating the water. And now this is times 100, right, because it's a percent. So divide by 100. So 99% when you divide is really going to be that 0.99 when you divide by 100, right? So that goes there, and this is going to be 0.99. This number right here is going to go here, and what we're solving for is this total energy. That is what we are solving for, and then that is going to go right into that. Okay, because we waste some energy. It's lost, we should say. Now, an electric hot water heater, we buy electricity from the electric company in something called kilowatt hours. And 1 kilowatt hour is equal to 3,600,000 joules. So we got to convert it into the type of energy that we buy. So we take the amount of joules and we divide by that conversion factor to give us kilowatt hours. That's probably going to be 3 to 4 to 5 to 6, somewhere in there. That should be a couple kilowatt hours. And then what you're going to do is we buy in, again, not the most updated, but this is the cost dollars per kilowatt hour. So if these are, for every kilowatt hour, you pay about 10 cents. So take that times the cost per kilowatt hour, and that gives you the cost to heat the hot water. Then we need to buy the water from the Village of Weston, and that's number 7 up here. So then we just simply take that number and we rewrite it here. And then what's the total cost? We take those two and we add those two numbers together. So my guess is this says less than $2, but it's probably going to be more like 60 cents, 80 cents, 40 cents, somewhere in that. It's probably going to be less than $1. Okay, now we're going to repeat the similar calculation, but this time we're going to say, well, what if it was a gas hot water heater? And this is a good thing to ask your parents. Do you have an electric or do you have a gas? And maybe, well, why? And probably the reason they're going to say is, I don't know, it was in the house when we got here, something like that. But that's a good conversation, and that's kind of what page 3 is going to get us into, is why would you choose one versus the other? So a gas hot water heater is very similar. We're going to use the exact same number from number 8. It's the MC delta T. You don't have to recalculate it if you don't want to, but you can. Then you're going to go through and you're going to do a gas hot water heater is about 70% efficient. So remember, this is 70%. This number goes right here times 100. We are, once again, solving for that, right? We're solving for the total energy. Now, we don't buy gas from Wisconsin Public Service. We're assuming natural gas, just for the record. Kilowatt hours, we buy it in something called therms. So there's a different conversion factor, and this is your conversion factor. So you need to determine how many therms it takes. Then we have to buy the amount of therms at the cost per therm, and that's going to give us how much money. Now, I made up some numbers earlier and I ran through. Mine was right around 20 cents. Okay, so then when we take this number and then we add it to the total cost of the water, which comes all the way back to part one that Will was talking to us about, then we can take the two numbers and we can add them together to determine our total cost. Now, this gas hot water heater shower should be less than the electric. So my made up numbers, this was like 65 cents and this is about 45 cents. So just keep in mind it should be less. And if it didn't, check your efficiency. This is 70 divided by 0.7. This is from number 14. You're solving for total energy. Okay, so at the end of page 1, you've figured out how much it costs to take a shower using an electric hot water heater and how much much money it costs to use a gas hot water heater. So then page 2 is really kind of looking through like, well, what's the differences and why would you? So I got a couple charts. So this is off of Lowe's website. This is an old Fleet Farm ad where they have electric hot water heaters and natural gas hot water heaters. And there's the comparisons. So I want you to kind of compare these things. So what's the cost of an electric hot water heater? And the idea is I want you to go through and try to size your hot water heaters based upon the recommendations, based upon your family size. So if it's 2 people in your household, you could get by with probably a 30 gallon. If you're 2 to 3, you could get by with probably a 40 gallon. If you're 3 to 4, and then if it's 5 plus. Now, for this activity, even if you are a family that's greater than 4, for the sake of this activity, I'm just going to ask you to pretend like you're a family of 4. And the reason is these hot water heaters I have in this ad only are 40 and 50. I don't have an 80 to compare. So just for comparison's sake, let's just pretend that you're a family of 4 if you're greater than that. So pick a hot water heater that's appropriate. So are you a 40 gallon or a 50 gallon? And then so really here, there's 4 different, there's a 40 gallon, there's a 50 gallon for $2.99, there's a 50 gallon for $2.99 and a 50 for $3.50. So there's tall versus like a standard size, so tall and skinny, but really just look at the gallons and then the warranties, the gallons and the warranties that go with it. And then what I'm asking you to do is find what's the cost of a comparable gas. So when I say comparable, if you're in this family of 4, you should be getting a 50 gallon electric, but a 40 gallon natural gas. So when you buy a 50 gallon that's got a 6-year warranty, you should probably make sure you get a 4-year with a 6-year warranty in terms of them being kind of comparable. And that's kind of what I'm looking at here, is size appropriately with similar warranties. So then we want to go through and figure out what the actual difference between the 2 hot water heaters that you pick. So if this is $199 and then this one is $269, what's the actual difference between those 2 hot water heaters? And that's really just taking the difference between those 21 and 20. Okay, and then what's the advantage of hot water? What's the disadvantage of electric hot water? What's the advantage of a gas hot water? What's the disadvantage of a gas hot water? So when you're looking at that, be thinking about like these. So upfront cost versus the cost to operate. This is kind of where your advantages and disadvantages are coming from. So then what I'm asking you to do is go back to the other page and look at what was the difference between your shower of your gas and your electric and figure out the actual difference. So in my made up example, I was right around 20 cents difference for every shower. So that means I'm going to save 20 cents by taking a shower using a gas hot water heater than I would with an electric. But my gas hot water heaters are more expensive up front. So then I'm trying to figure out how many showers do I have to take to make up that difference. So that's what this step is taking you through, is you can go through and say, well, my difference was like $100, but if I save 20 cents every time, how many showers would it take? That's the idea of 29. Now, that's just how many showers. So then let's go with this assumption that I take one shower a day, 365 days a year. How many showers or how many years how many years, sorry, would it take for me to make up that difference in cost? So how many years would it take to make up that $100 upfront cost by saving 20 cents every shower? That's what this is. So for me, I think this number was probably right around a year. Okay, it should probably be right around a year. It might be more, it might be less, depending on how long your shower is. Then most of us don't live by ourselves. So like there's 4 people in my household. So what if every person in my family showered exactly like I did with the same amount of hot water that I did? And I know that's not the case, but let's just make that assumption. How many years would it take? So take the number of years divided by the number of people in your family, and then you can get how long would your family take. And that really kind of, I think, is an interesting number to figure out, like, hey, this costs more, but it's really, the payoff period is pretty quick. So then this question number 32, and our final question, is really trying to get you to think about, well, why would I buy an electric, or why would I buy a gas? And what are kind of some assumptions that you got to make? So like we have a cabin, and at our cabin, we don't have natural gas running to our cabin. So a natural gas hot water heater isn't an option. Now we could go propane. We could use electric. So those are kind of my options. So some of you I know don't have some of those options. At my house, we have a gas hot water heater, but our electric service would need to be upgraded in order for us to do that. So there's some kind of assumptions that we're making. But if you had the choice, what would you do and why would you make that choice is kind of the idea. And then when you're done with that, I had said that you should probably make your calculations on a separate piece of paper. If you want to do it over here in the margins because you want to mark up this document, go right ahead. But then take a picture of this and submit this. And this is the last activity that I have for you during this offsite time. So thanks for sticking with me during this time. I hope you did okay. Congratulations on finishing. The rest of the week is really just meant for catch up. For any other activities that you still have from this unit that you want to get turned in and get graded. So have a great week, everyone.